Hey everyone, we're going to start in about a few minutes. We're just waiting for everyone to join and then we'll start. Okay, hi everyone. Are you guys able to hear me? Just drop a quick yes or no in the chat. Am I audible, everyone? Just quickly drop a yes or no in the chat, guys. Okay, cool. Let's start. Just allow me a minute. Ev- Um, Let me share my screen. Are you guys able to see my shared screen, everyone? Okay, cool. So we already talked about a basic few things around abstract classes and interfaces already, right? Now, what I'm going to do is I'm going to give you guys a situation. And in that situation, we will be using inheritance. And I would like you guys to pause yourself and think about what is going wrong with the given set of classes which are inheriting from each other. What is the problematic scenario? What is not going well? When it will not go well? When it is good to go? All the situations I want you guys to think, right? And then we'll start talking about like I'll give you my perspective of what is not going well. Okay. So let's start implementing. Okay. So I'll create a new package. Okay. I'll call it as a problematic code. Okay. And let's prepare a set of classes to see what can be done. Okay. Let's create a new Java class. And I'm going to like rely on abstract classes for now, right? Just to show you kind of like a sense of inheritance, right? So I'll prepare a new class credit card. Okay. Just a second, guys. Just a second, guys. Just give me a minute. Okay, let me share the screen again. You guys can see the shared screen now. Everyone can see the IntelliJ. Okay, cool. So let's say we are preparing a, let's say I'll prepare a public abstract class credit card. Okay. And there are going to be a bunch of abstract methods in this credit card. So for example, let's say you're going to have public abstract void tap and pay. Okay. A lot of credit cards support tap and pay, right? So let's say we have an abstract method tap and pay. Then let's say we have a public abstract void online transfer. Okay. Then let's say you have a public abstract void mandate payments and so on. Okay. Mandate payments are like, for example, you set up a recurring SIP, or let's say you have a Spotify subscription. Every 6 months, that subscription renews. So you set up a payment mandate. Okay. Kind of like that kind of a situation I'm trying to mimic. Okay. Now, and for the timing, let's not even keep them abstract. Let's go step by step. Let's say these are the methods. Okay. If I ask you to set up a, I would say, payment mechanism in which different type of credit cards are supported, I believe the first thing that might come to your mind will not be even an abstract class. It will be a situation where you have a credit card class and you are supporting a tap and pay, you are supporting an online transfer, and you are supporting a mandate payment. Okay. This will be the V1 that will come to your mind, that I'll say, I'll ask you that, okay, we are a credit card, let's say we are a bank, right? And we want to issue credit cards to users, and we want to implement some functionalities of the credit cards, right? So this will be the first thing that should come to your mind, right? Okay, that okay, our credit card will support tap and pay. Our credit card will support online transfer, swipe and pay. Let's say there is, let's say, a method public void swipe and pay, right? Then let's say there is a mandate payments method. The different type of functionalities our credit card will be having. Okay, so we will go to our stakeholders and we'll say that, okay, now we are going to support, we have like our bank is now going to support credit cards, and these are the different type of payments that our bank can support. So our stakeholders will mention that, okay, in order to make sure that we are able to issue credit cards, it's not like we can directly issue credit cards. There are payment, I would say, gateways, or you can say payment authorizers like Visa, MasterCard, RuPay, right? We need to actually integrate with them, right? And because Visa works in an absolutely different way, Visa will be exposing their own set of APIs to us. MasterCard works in a very absolutely different way. RuPay works in an absolutely different way. So one credit card class won't work for us, right? Because how tap and pay works in a Visa credit card might not be similar to how tap and pay works in a MasterCard, right? So that means we cannot have just a single credit card class that will work for us. That's why we'll go to the implementation that, okay, we are going to have different type of credit cards. So let's do one thing. Okay. Because tap and pay, mandate payments, all of these can be handled in a different way, right? Let's add one more abstract method, public abstract void swipe and pay. Okay. So let's say different credit cards are going to support different type of payment methods, right? Because how Visa is going to implement tap and pay is going to be different than how MasterCard implements tap and pay. So we are going to keep them abstract, but few of the details will be similar, right? For example, if we want to get the credit card number, or you want to display the credit card number, or you want to display the credit card owner, these kind of details, let's say we want to have, for that we can have a common implementation. For example, let's say we do public void display credit card details. Okay. Kind of like this, details. Okay. So let's say every credit card is going to have what? Let's say a credit card number. So let's say private string CC number. Okay. Private string CC number, right? And let's say every credit card is going to have a private string owner name, right? Something like this. Then a private number int CVV, right? These, let's say, are going to be the properties of a credit card, right? Every card will be having a credit card number, owner name, and a CVV, right? And whenever you want to display a credit card detail, then what we are going to have is, we are going to say, let's say system.out.println. We are going to say credit card number is, let's call it like this dot CC number plus comma with owner name as this dot owner name, because we should technically never expose the CVV, right? We should technically never ever expose our CVV. So CVV will not display. Okay. And let's say this is a common method, right? It's going to be a simple common method altogether, right? How cool is that? Now, let's say we also are going to have getters and setters for our a credit card number, owner name, and CVV. Let's have our getter setters as well. So I'll say public void set CC number. Okay. And let's say we are going to get a string CC number, and we'll say this dot CC number is equals to CC number. Okay. We are going to have a setter like this for everything. So let's say set CVV. We are going to get a int CVV, and this dot CVV is equals to CVV. Okay. And similarly, set owner name, string owner name, and we'll say this dot owner name, owner name. Okay. So let's say we are going to have common getter setters, whatever is the credit card, MasterCard, RuPay card, Visa card. Every credit card has these three details, right? Every credit card has these three details. Okay. So you can say that we can have some common properties, and this is the benefit of an abstract class, right? Instead of a, you can say, interface, this is the benefit of abstract classes, that you can even say you can have even common class properties as well. Okay. And then we are going to have abstract methods, tap and pay, online transfer, swipe and pay, mandate payments. Whatever is the credit card issuer, Visa, MasterCard, they will be having their own set of implementations. So how does that look like? So let's say, because now Visa is a credit card, like whatever Visa card you will issue, it will be a credit card. MasterCard card is a credit card. RuPay card is a credit card. So there is a relationship. Whenever there is a relationship, the first thing that comes to your mind is what? Inheritance, right? So let's say I'll implement a let's say Visa class, Visa card class. Okay. Public class Visa card. What we are going to do is we are going to extend to let's say our credit card class. Okay. Now there is an error. Why? Because credit card is an abstract class. There are some abstract methods. So we need to implement all of these abstract methods, right? Tap and pay, online transfer, mandate payments, right? So I'll say system.out.println tap and pay implementation of Visa. Okay. Copy, paste, online transfer, some implementation. How this implementation goes, we are not going to go into that, of course. Right. And then swipe and pay implementation. And let's say mandate payment implementation. Okay. So you can see Visa card is now extending from a credit card, right? And you can see that there is a tap and pay, online transfer, swipe and pay, mandate payment. Okay. Very simple. And I'll copy everything from here. And let's say I'll create one more class, MasterCard. Okay. MasterCard. And I'll call it as MasterCard. Okay. And MasterCard has its own set of implementation. So let's say instead of Visa, we'll say MasterCard. Okay. And same thing is going to happen for RuPay card. RuPay card. Okay. So I'll copy everything from MasterCard, paste it here, and we'll call it as RuPay card. Okay. And let's say this is an implementation of RuPay. Okay. I hope everybody knows about Visa, MasterCard, RuPay, right? If you want to understand what is this Visa, you can just have a quick Google search, right? What is Visa and MasterCard? Okay. So see, there are payment gateways, right? These are payment networks, right? So if you have heard about, let's say when the Russia-Ukraine war happened, then as far as I remember, then Visa and Mastercard stopped their payment in Russia. So people who had Visa and Mastercard issued cards were not able to make any payments, right? Because their payment network doesn't allow anything. And why do you need a payment network? Because you need some standard set of protocols, right? To actually make sure that the payment happens, so that payment are secure, payment has a certain set of rules that they are following, so on and so forth, right? So similar kind of a thing. Let's say you are a payment gateway and you are implementing, or let's say you're a bank and you want to start issuing credit cards. This is how you might actually do it. Okay. Now, I have taken this as a very real life example. Okay. Now I want you guys to pause yourself here, because Visa is a different entity, right? It will be having its own set of features that may or may not be present inside MasterCard. And similar thing as RuPay. RuPay is a made in India kind of a payment network, right? So think about it. Is this set of classes, whatever I have prepared, is there any problem with this? Is the inheritance that we are doing can cause any issues? Can we land up in a situation where there will be code cleanliness problems? If yes, then when? Try to think about a situation that when can a code cleanliness problem can occur, and then start thinking about how can you actually resolve it. Make sense, everyone? Are the set of classes clear to everyone? I'll push it as well. So that you guys can have them within yourself. Added problematic code for lesson 4. Here we go. Guys, are you able to get my point? Whatever I have discussed as of now. Do you guys understand it? Everyone, do you guys understand what actually happened here? There is a credit card class. Every credit card will be having its own way of making tap and pay happen, online transfer happen, swipe and pay happen, so on and so forth. Now you have to figure out what can be a potential issue in this kind of a class implementation and how can you actually resolve it. Got it? Yes. Sujit, you are thinking in the right direction. What will you do in that case? Okay, so we have a bunch of responses. Let's go through all of them one by one. Omkar says, what if a card has a failure while making a payment and throws an exception at Java node, while other cards don't? We are ourselves implementing, no, Omkar. So we have to make like it's kind of like asking that we are making a sign up form, and what if on the backend we have not implemented the logic of sign up? We are supporting these cards, no? On the Java, whatever exception, these cards are expected to throw some exception. Whatever exception they throw, in our classes, we are going to handle it, no? We are going to at least on logical level handle it, right? We might want to disable few payment options in a particular card. So we will have to provide some other implementation every time. Makes sense. Very nice observation, Akash. Abhijit says, we can define credit card as an interface and 4 different abstract classes. Now each card is a but why do you want to do it? Reason तो दो. मैंने अच्छा तो जस्ट FYI है इस एग्जांपल को सोचने के लिए ना मैंने 3 घंटे खर्च करे कि क्या रियल लाइफ सिचुएशन में तुम्हें बता सकूं जो तुमने खुद भी एक्सपीरियंस करी हो कि ये प्रिंसिपल समझाना मैं तुम्हें अच्छा एक चलो ठीक है चलो डिफरेंस बिटवीन एल्गो कैंप एंड गूगल तो मैं दिखाता हूँ मैं अगर तुम इंटरनेट पे जाओगे ना और तुम बस इतना लिखोगे लिस्कॉव सब्स्टिट्यूशन प्रिंसिपल एग्जाम्पल मीडियम मैं शुरू के 5 मीडियम आर्टिकल्स दिखा रहा हूँ फिर नॉन मीडियम आर्टिकल्स भी दिखाऊंगा ठीक है पहला मीडियम आर्टिकल व्हाट इज द एग्जाम्पल टेकन कलर्स ग्रीन कलर ब्लू कलर कलर बेस्ड एग्जाम्पल कोई रियल लाइफ सिचुएशन नहीं है सेकेंड आर्टिकल शेप्स और ये शेप वाला एग्जाम्पल हर जगह मिलेगा तुम्हें अभी देखते जाओ थर्ड एग्जाम्पल रेक्टेंगल्स सेम शेप्स ठीक है फोर्थ आर्टिकल बर्ड्स ठीक है कोई रियल लाइफ सिनेरियो ही नहीं है मीडियम हटा देते हैं स्टैकिफाई उसके बाद तो एक मीडियम का ही आ रहा है और ये रिफैक्टरिंग आयो ले लेते हैं इनमें देखते हैं क्या एग्जांपल्स हैं ठीक है मैंने पढ़ा नहीं है स्टैकिफाई कॉफी मशीन ये वो कॉफी मशीन एग्जांपल यहाँ देख लेते हैं क्या है यहाँ पे फिर भी एक क्रेडिट कार्ड बेस्ड कुछ क्रेडिट कार्ड और डेबिट कार्ड का एग्जांपल है सो रिफैक्टरिंग आयो में स्टिल यू हैव तो मतलब हमने 10 आर्टिकल्स ऑलमोस्ट चेक करे एक वेबसाइट पे स्टिल थोड़ा रिलेटेबल एग्जांपल है और अभी जो मैं तुम्हें एग्जांपल बताऊंगा इसको तो मतलब एग्जैक्ट फीचर इंप्लीमेंटेशन ऐसे ही है ठीक है तो ट्राई टू नॉट जस्ट सॉल्व इट ट्राई टू थिंक व्हेन दिस इशू विल अकर चलो लेट्स टॉक अबाउट इट ओके जस्ट अ सेकंड जस्ट अ मिनट जस्ट अ मिनट ओके So this is the situation in front of us. Let me help you revise what's the set of classes we have. We have a credit card class. It's an abstract class. It has some implemented methods, a few setters we have, a display credit card detail we have, and a few abstract methods. Why abstract method? Because we are going to support different kind of credit card payment networks like Visa, MasterCard, RuPay. Every payment network might be implementing things in a certain way. For example, how tap and pay works in Visa might be different than how tap and pay works in MasterCard and how tap and pay works in RuPay card. Similarly, how online transfer works in RuPay card might be different because these payment networks might be exposing their own set of APIs, right? Their own set of APIs to us. So how things are going to be implemented because maybe we have to call a MasterCard API for online transfer. For Visa card, we have to call a Visa API. Of course, there will be different set of APIs that will be exposed to us. What is the issue with these set of classes? Now, different payment networks are not always expected to have same behavior. These are all behaviors, right? Tap and pay is a behavior. Online transfer is a behavior. Swipe and pay is a behavior. Mandate payments is a behavior, right? Not all credit cards might be having same behavior. Let me give you an example. So if you have ever used UPI, that is one of the most widely used payment mechanism in India. If you will search for credit card with UPI, Okay. The only credit card network that supports UPI payment is RuPay as of now. That means if you want to implement a method like public abstract void UPI payment, the problem here is in RuPay card has its own set of implementation. RuPay card does support. So that means RuPay network will be giving us an API to support UPI payments, right? So you can do RuPay on UPI. Okay. UPI payment implementation of RuPay. But problem comes with Visa card and MasterCard. They do not support any UPI payment, right? So what will happen in their implementation? Like in Visa and MasterCard, if I override the methods, what do I need to implement here? Right? Either you will be keeping these methods, let's say if it's a void or some specific type, you will be returning some default values, or maybe you will be throwing exceptions, throwing not implemented exception. So there is a exception. You can do throw new not implemented. I guess there's a no such method exception, kind of like this. No such method exception you are going to throw. But this is also a problem, right? Because you are forced to do it. Think about it like this. You are implementing a UPI payment method inside Visa card, which is going to, let's say, throw a new exception. You are forced to do it, right? You are forced to do it. Ideally, this behavior should not even exist for Visa card. You are making this behavior exist for Visa card and making it throw an exception. So you are forced to implement it, right? There's a forceful exception throw that you have to actually do it here. And think about it like this. Let's say for a moment, let's say there is a main class. Okay. Public static void main. Okay. Now let's say you have a list of credit cards. Okay. So let's say you have a user who have 4 or 5 different credit cards. Some of the credit cards are MasterCard. Some of the credit cards are RuPay cards. Some of the credit cards are Visa cards. Now, let's say this is a new array list. Okay. And let's say there are a bunch of card objects present here. And we want to actually attempt a payment from all of the possible cards. Whichever is the first card that can help us to attempt the payment, we are going to technically try it, right? Now just think about it. How do we know which credit card supports UPI payment or not? What we will be doing is we'll be saying, let's say void credit card in cards. Okay. And we are going to say that if, let's say, card is, if card instance of, let's say, RuPay card, then only we are going to make a payment of card dot UPI payment. Can I say that? Now there is a problem, right? This is ideally a problem. Why? Because this is making us lose the possibilities of abstraction, the abstraction principle, right? Ideally, whenever there is a module, assume that this main class is a module. Okay. This module needs to depend on credit card, right? This ideally need not to know. Anyway, it should not be knowing that what are the different possible instances of a card. Like a card can be a RuPay card, a card can be a Visa card, MasterCard. Ideally, in an ideal scenario, this should not have been the case. And having these if checks are going to be very painful. Think about it like this. Let's say now you want to make an international payment. Okay. Let's say you want to support a method, public abstract void international payment. Now, RuPay card is a made in India card, and there are a lot of countries that might still not support RuPay card. I'll tell you an instance. So when I was in college, I wanted to buy a Udemy course, and I was having a debit card issued from Union Bank of India. which was a RuPay card. It was a RuPay network debit card. That card didn't used to work on Udemy, because at that point of time, Udemy, because that it's an I would say out of India company, right? So they had their own payment gateways and everything, and that payment gateway didn't support RuPay card. So international payments, if you want to do, still the ideal way to do international payment will be a Visa card and a MasterCard. But if you have a RuPay card, then ideally no international payment should work. So similar problem will exist. What will happen is inside MasterCard, so you will implement international payment very easily, right? Inside MasterCard, so you will implement international payment of MasterCard, right? And same thing you will do for Visa card, that very easily you have to do international payment of Visa. But what will you do for RuPay card? Again, specific handling you have to do, right? You might be throwing some exception which you are forced to do. If a RuPay card is a credit card, then every property of a credit card should be kind of like common, right? That's the behavior of inheritance. That's what inheritance always taught us, right? If you remember very simple examples of inheritance, that a truck is a vehicle, a car is a vehicle, a motorbike is a vehicle, every vehicle can run, every vehicle will be having a speedometer, kind of like that, if you remember those kind of examples. But we are violating it straight away here. And think about it like, again, any module that is depending on credit card, in that module, if you want to allow international payments, then we have to do logical checks that card is an instance of MasterCard or Visa card, then only we will allow international payment, right? Ideally, if we have to do an international payment, so technically the situation should have been something like this, that we should have credit card which supports international payments already. So we should have a list of international payment supported credit card, kind of like this, cards, right? And then all of the cards inside list should automatically always support international payment, and we should just call card.make payment of international payment. Or let's say we should have a list of UPI supported credit cards, and ideally all of the cards inside this list should support UPI payment, right? So now I want a situation that how should I manage my classes that few of the cards are going to have common properties, right? These cards, few of the cards have common properties like online transfer, swipe and pay, mandate. These are common behaviors, not even properties. We should call it as behaviors. That these cards have online transfer, swipe and pay. All of these are common behaviors. That's good. But few of the cards will be having specific behaviors that other cards might not possess, right? What can we do in that case? And this code, as of now, directly violates one of the most important solid principles called as Liskov substitution principle, right? This is called as Liskov substitution principle. Now, what is Liskov substitution principle? Liskov is the name of the person who actually introduced this principle altogether, right? There was Barbara Liskov. If you will Google about Barbara Liskov, right? This American computer scientist, I guess in 1987, introduced Liskov substitution principle, right? What does Liskov substitution principle say? Liskov substitution principle says that the subclasses, what are the subclasses here? MasterCard, RuPay card, Visa card, because we are doing inheritance. Inheritance means we are doing a is-a relationship, that Visa card is a credit card, RuPay card is a credit card, MasterCard is a credit card, right? So this is a relationship. That's why these are subclasses. So subclasses should be substitutable for their base classes without altering the correctness of the program, right? That means at any point of time, if we want to have credit card here, right? Because all of the behaviors are common in the credit card, we should never have a situation where we have to do some specific kind of handling, right? We should never have a situation where we have to do some specific kind of handling for any kind of a, I would say, subclass. Because you can see, we are saying card is an instance of RuPay card. That means what's happening? We are doing a very specific handling for a one type of a subclass, right? Same thing, if let's say we will introduce international payments, we will be doing a specific kind of handling for international payments. And this is the problematic scenario. This is the problematic scenario that I'm talking about, right? So this is the violation of Liskov substitution principle. How many of you guys are able to get at least what is the violation here? I'm going to give you one or two more examples to understand Liskov substitution principle, and then we are going to make this problematic code go in a better form. But first of all, let me know what you guys think about whatever we have discussed as of now. Do you guys agree with the pointers, and do you guys agree with the situation? Do you guys agree with the situation what we are doing here? First of all, tell me that. Liskov substitution principle, I believe, is very easy if you go with right set of examples, right? Otherwise, you will realize that most of the people understand only two principles in solid principle, SRP and OCP, because after that, LSP comes and they start losing the grip. So I want you guys to have a fair understanding, because I'm going to give you a bunch of more examples. Let me connect my iPad so that we can discuss a few more examples. But before that, I want to see, are you guys in consensus? Do you guys agree what I'm trying to say here, so on and so forth? I'll come to interface segregation principle as well. Ideally, yes. On a good level, this also violates that, but I will come to that example in a moment. Technically, the resolution that we are going to do for Liskov substitution principle is going to ideally help us resolve the interface segregation principle as well. But let's go step by step. Let's go step by step. Right. Technically, interface segregation principle says that what you are doing wrong on Liskov substitution principle, if that happens on a scale of 10x, so that will lead to a lot of class explosion and everything. And that's where interface segregation also comes, but we'll come to that. I want to go step by step. But yes, on some level, yes, this also violates that interface segregation principle. Okay, let me share my screen, guys, and my iPad screen, and let me know if you guys are able to see the iPad screen. Can you guys see my iPad screen? Okay, 1 second. Okay, let's talk about it. So let's try to understand Liskov substitution principle in a bit more in depth. Okay. Now, Liskov substitution principle gives us a direct, I would say, example of problems that might come due to inheritance. Now, why did we use inheritance? Generally, if you will see people using inheritance, or you will see people using inherited, like say subclasses, and they have some parent classes, all of these things, whenever you will see people doing, they do it for one cause. If you will ask, no, that why you did inheritance, they will do it. They generally will tell you one cause, that they did it for reusability of code. Okay, that let's say you have a superclass, and then let's say you have some child classes, let's say subclass. Then generally people do inheritance because they want to implement reusability, right? They want to enhance reusability, right? Okay, and these are what? Derived class. You also call them derived class. Why do you call derived classes? Because any method that is public and protected in the superclass will be also available for your subclasses. Okay. Now, let's take an example. Okay, let's take an example. Let's say there is a superclass employee. So you are, let's say, making a salary management system where you are going to, like, your project is to make sure that different type of employees get their own set of salaries and everything. Okay. Now, let's make this employee class as an abstract class. Okay, cool. And this employee abstract class, let's say, has a calculate salary method. It has a calculate salary method. Okay. Now just think about it. What can be different type of employees in your company? One employee can be full-time engineer or full-time employee, FTE. One type of employee can be interns. There can be vendors who are contractual employees, and so on, right? Now, all of these, you can say FTE is an employee, intern is an employee, vendor is an employee. Can I say that? Why? Because FTE is also going to get some salary, intern is also going to get some salary, vendor is also going to get some salary. Now, ideally, we should make this salary method abstract. Why we should make this salary method abstract? Because how the salary of FTE is calculated is different than how salary of intern is calculated. Why? FTEs get benefits. For example, some part of your salary will be going in your public provident fund. Because you are an FT, you might get some stock options as well, right? Some part of your salary might go, because you're a full-time employee and some part of your salary goes in public provident fund, the company also has to add public provident fund in your salary, right? So on and so forth. There will be some dedicated bonuses that might come on in few months and so on. But that's not the case with interns and vendors. Interns do not get any full-time employee benefits. Same with vendors. Vendors also do not get some full-time employee benefits, right? Interns are there for some strict schedule, like there might be a 6-month intern. So they will only get salary for 6 months. But vendors can be for a longer period of time. For example, if you will go to companies like Microsoft, Google, right? We have a lot of vendors, right? These are contractual employees that we hire from companies like Accenture, who actually helps the full-time employees in some of their tasks. Any redundant task is there, then that redundant task generally goes to the vendors, right? So vendors stay for a longer period of time than interns. Interns will be having a strict total schedule, so on and so forth. So there will be different ways in which all of these employees are going to get salary, but all of these employees will get a salary. All of these employees will get a salary, right? That's why making the calculate salary method abstract makes sense, because all of them will be having their own set of implementation for calculating a salary, right? So you can say FTE, intern, and vendor follow strict is a relationship. Strict is a relationship with employee. Okay. Now, by the time you have a situation like this, things are going to go well. But let's say at some point of time, for some special events, your company is going to hire some volunteers. Now, if you have a volunteer, volunteers work for, because they have volunteered for it. They don't get a pay for it. If you will make a volunteer also an employee, then what are you going to do for calculate salary of a volunteer? Calculate salary will be there for FTE. They are full-time employee. They get stock options, public provident fund, base salary, so on and so forth. Interns also get, but for some period of time. Vendors also get regular salary, but no full-time employee benefits, like vendors won't be having PPF components and everything. What about this volunteer? Technically, there should not be any salary calculation for a volunteer. They are one time, they are there for a one-time event, and for that also they don't get paid. But if you make volunteer also an employee, that you extend volunteer class, extend the employee class, then you have to override the calculate salary method here. This is the same issue that happened with our credit card mechanism, that some of the subclasses are going to have the common I would say common behavior, but few subclasses might not be having the common behavior, right? For example, in our case also, what example did we took? We took a credit card example, that there is a credit card, right? Now a Visa card is also a credit card. A MasterCard is also a credit card. And a RuPay card is also a credit card. Now, they are credit cards, but they do not possess all common behaviors. Visa possesses some different behaviors. Master possesses some different behaviors. RuPay possesses some different behaviors. So you cannot say Visa, MasterCard, and RuPay have a strict is a relationship with credit card. Because if credit card exposes a bunch of abstract method, not all of them support all of them, right? This is a problematic scenario for us. This is a problematic scenario for us, right? Now, let's come back. Now, what will you do for this volunteer? Again, similar thing that we are doing for UPI payment inside Visa and MasterCard. Either you will be, let's say, returning a zero that they won't be having a salary, or you will be throwing some exception. But the problem still exists that you are forced to implement these methods that should not have even existed in the first place. Calculation of the salary for a volunteer is not a behavior that a volunteer should possess. We're talking about behaviors here, right? This is one thing. Apart from that, we saw one more issue that if there is a third party module, let's say there is a module like salary disburser, right? This salary disburser takes a list of employees. Let's say there is a cron job that you have set up every month on the 30th of every month. This salary disburser class is called automatically, right? You have prepared a scheduler. It takes a list of employees, and for every employee, it calls the calculate salary method, and whatever calculate salary has been calculated, then it calls make payment method. Okay. So it will first of all call calculate salary, and then it will call make payment. So either if you have thrown an exception, then you have to do conditional checks here. That if an employee is an instance of volunteer, continue. Do not do anything because it will eventually throw an exception. Or if you will be having some random number disbursed, like zero, then you are going to call make payment with a payment of zero. So let's say make payment calls the payment gateway. So inside your payment gateway, there will be a log of a payment to a volunteer of 0 INR, right? That payment should never have even started in the first place, right? So you can see this module of salary disbursement, right? Because it depends on an abstraction employee. It should not care about what should happen for the particular employee. What should happen with a particular employee should be happening inside their own set of classes. This module should not care about special cases like volunteer. And this leads to violation of Liskov substitution principle. Liskov is the person who prepared this principle, and substitution is something that they actually talk about, right? So few pointers that Liskov substitution principle, I would say, suggest is that inheritance might not be the best way always for reusability, right? If you're targeting reusability, then there can be a case that inheritance might not be the best way to do it, right? There can be a situation like that, okay? And even if you want to use inheritance, right? Let's say you are having a situation where you want to use inheritance only, right? Then there should be a strict is a relationship. Do inheritance if and only if there is a strict is a relationship, right? Right. Now, this is the situation we have. This is the situation we have. Okay. So what Liskov substitution principle says, if you talk about the actual, I would say, logic, right? LSP says that subtypes must be substitutable for base type. That means here, where let's say a third party module has to depend, this third party module should not depend on actually these subtypes or subclasses, right? These subclasses should be substituted by the parent class, right? And we should ideally directly use this parent class to make things happen for us, right? This is what Liskov substitution principle actually suggests, right? So if I describe it a bit more, if I try to describe it a bit more, it says that objects of a child class should be as it is substitutable in variables of parent class. Same thing, right? What is the variable of the parent class? You can see this list is the variable of the parent class. Now, technically, we should be able to directly inject object of FTE, intern, vendor, volunteer, whenever we want, directly. There should not be any corner cases, or there should not be any specific handling that you have to do for any specific type of a child class, right? They should be directly be implementable. This is something that Liskov substitution principle actually suggests. Is this point making sense to everyone? If we talk about a few things in a simple terms, then and like the cases that we have discussed as of now, then a few more pointers that adds up to the LSP is that no change should be required in the code base to accommodate a specific child class. A specific child class. Okay. Or you can say child classes should not need special treatment. Right? They should not need any special treatment. And child class should do exactly what the parent class expects. Right? That means if a parent is expecting, like who's the parent? Credit card is the parent. Credit card is expecting a UPI payment, then child class should do UPI payment, right? Think about it. If you're reading that, like, think about it. If let's say you do not know the rule, if let's say you do not know the rule of, like, think about it, a very real life situation. Let's say you do not know the rule of government that only RuPay card supports UPI payment. You will assume that, right? RuPay card is also a credit card. Visa is also a credit card. MasterCard is also a credit card. You will, and let's say you have two credit cards. One is issued by Visa. One is issued by RuPay. What will you think? Both are credit cards. If both are credit cards, both should have similar kind of features. Both should work in UPI. Right? Because people are saying both are credit cards. Credit cards should have common behavior. Right? But we have to give special treatment to RuPay card. So when you will realize, oh, RuPay card doesn't work for UPI payments, then you will realize, oh, RuPay card has some special features. Or I would say special case. It's not like a general credit card. Like, let's say if you go to a country like London, every credit card that you will buy in London is either a Visa card or a MasterCard. As far as I know, they don't have their own payment network. They rely on Visa and MasterCard. So every credit card in London will be having support of international payments. But in India, that doesn't work directly, right? In India, you can get either a Visa card or a MasterCard or a RuPay card. Then few of your cards will support international payment. Few will not, right? So these cannot be just clubbed like regular credit cards. They will be having some special behaviors as well, right? This is what Liskov substitution principle says, that you cannot just replace, if you have to use RuPay card specifically somewhere, you cannot just say that, okay, RuPay card is a credit card and I will always use the abstraction of the credit card everywhere and RuPay card will be automatically handled. No. You have to give special attention to RuPay card. And that is also not a very good thing, that you are specifically handling things for RuPay card. So all of this combines Liskov's substitution principle, that subtypes must be substitutable by the base types. That instead of using RuPay card CC is equals to new RuPay card, it should have been very easy to do credit card CC is equals to new RuPay card. And then you just use the credit card abstraction everywhere, right? That's what Liskov substitution principle says. Now, the question that should come to your mind is, okay, sir, we understood what's the situation. We had two examples that very much identify the situation with us. How will you resolve it? Right? That should be the next question that should come to your mind. How can we have this situation go in a better direction? Are you guys able to get this point? Guys, is this question coming to your mind that, okay, things are good, but how to resolve it? A few of you already gave few nice solutions. Okay, let's think about it. So now, because we can have different kind of behaviors altogether, let me make a new package. And I'll call it as better code. Okay. I'll copy all of the classes from my problematic code to better code. Paste. Okay. Right. All of the classes are here. Now, I will say that not every card is going to support UPI payment and not every card is going to support international payment. So let's remove them. Okay. Not every card is going to support UPI payment and not every card is going to support international payment. Every card definitely support these four. So let's keep these four in the same credit card abstraction and let's have a new interface, right? Now, because we cannot have multiple credit cards, like we cannot extend multiple classes. So a good way would be to create a new interface and call it as UPI compatible credit card. Okay. Let's make it an interface and we will say that every class that implements this interface will be having a UPI payment method. Okay. Similarly, let's create one more interface. International payment compatible credit card. And let's call it as void international payment. Okay. And then if RuPay card, now we don't need these overrides. If RuPay card has to support UPI payment, it will implement UPI compatible card interface and it will be having its implementation of UPI payment. How cool is that? UPI payment of RuPay. And let's say Visa card, let's say Visa card and MasterCard has to support international payment. So we'll say implements international payment compatible credit card. Okay. And we will say international payment of Visa and same thing with MasterCard. We'll call it implements international this and implement methods. And we will call international payment of MasterCard. And now let's say you have a module. This module has to do what? This module has to call international payments, that it has to, whatever is the first card that let's say supports international payment, it has to, from all of your credit cards, it will be actually fetching only those cards which support international payment. So now you don't need to make a list of credit card, right? You don't need to make a list of credit card. Instead, you can make a list of international payment compatible credit cards. Can I say that? And card in cards, let's make it cards, you will call card dot international payment. Now you can see this doesn't do any specific handling because this interface already knows that these are only those interfaces, or I would say this interface will be implemented by only those classes which has international payment. And now think about it. This main module and this main module, which has lesser tight coupling with the classes. This one has lesser tight coupling, right? We should always try to implement classes, or at least try to make sure that as much as possible, we try to reduce the amount of coupling, because the more coupling you will do, the more violation of single responsibility principle and OCP will also happen. Because then every time you have a new behavior, you are going to change your main class, right? So this is going to actually create a lot of chaos. And that's where things like Liskov substitution principle comes into the picture. So I'll push this code. Here we go. Make sense, everyone? समझ में आया क्या करा हमने, कैसे करा, क्या प्रॉब्लम है? गाइस सबको समझ में आ रहा है? एक बार ही हम लोग refactoring.io वाला एग्जांपल भी पढ़ ही लेते हैं, उसमें भी कुछ कुछ रियल लाइफ सही लग रहा था एग्जांपल, तो उसको भी एक बार ही देख ही लेते हैं, ठीक है? तो क्या सर्च किया था, ठीक है? So there is a similar example on refactoring.io. You can see violation of LSP, an example. So there is a abstract class payment instrument, right? This abstract class has a validate method, run fraud checks, send to payment gateway. Okay. What is validate? It does basic validations. Fraud checks for frauds against some third party, let's say ML algorithm or something. And send to payment gateway. This sends the details to the payment gateway. Now, a credit card can also be a payment instrument. A debit card can also be a payment instrument, right? Okay. Now, credit card overrides the validate method because apart from the basic set of validations that are done for every instrument, maybe credit card needs some more validations. Debit card doesn't need, let's say, extra validations. Now, you can see we have a payment processor. This payment processor is calling on every whatever is the instrument that has been passed, it calls validate on that instrument, it calls fraud check on that instrument, and then it calls send to payment gateway, and then it saves the details of that instrument here. Okay, now let's see what do they say. They say that a different area, and you can see this is a third party module like our payment disburser or the main module that we had, which is going to use these abstractions. Now you can see it is not using credit card or debit card, right? Because it is depending on an abstraction. You should always try to depend on abstractions, right? Cool. Of course, in an actual production system, there would be many complex aspects to handle. The single processor class above might well be a bunch of classes in multiple packages, right? So there can be multiple dependent packages like these. Okay, cool. Now let's see. When you call save to database, you're calling payment instrument.get fingerprint, right? Okay, cool. Now let's see what do they say. At some point, the marketing team decides to introduce reward points to increase customer loyalty. Customer get a small number of reward points for each purchase. They can use points to buy products on the site. Ideally, we should be able to add a reward class that extends payment instrument and to be done with it. But we find that adding it violates LSP. Let's see how. So if we will add a reward class, reward card class, then it will violate LSP. Let's see how. There are no fraud checks for reward cards, right? Details are not sent to payment gateways, and there is no concept of a fingerprint identifier. So you are actually introducing, apart from your debit card and credit card, you are introducing a reward card. It's kind of like not a payment card, but you can say whenever you make a purchase through your credit card or debit card, you get some points in your reward card. Kind of like if you have seen Starbucks card. Starbucks card is kind of like a reward card. Whenever you make a payment, you get some additional brownie points in that card, and then you can use that Starbucks card to, let's say, swipe somewhere only in Starbucks only. Now, a reward card, this is also a payment instrument, because on your website, you will be able to pay through reward card. But for reward card, you do not need any validate. You do not need to run fraud check. You do not need send payment gateway, right? That means if you are saying payment instrument is a parent class, credit card, debit card, and reward card are child classes. There are not, all the behaviors are not common. All the common behaviors are not required. See, this would still break the application. We might get a null pointer exception from save to database method once fingerprint would be null. Can we handle it in a better way? Right? Yes. So what you will do is, let's say you have a payment instrument interface, right? This will be having a valid, collect payment, things like this. And you have a payment processor, right? Now what will happen is, you will be having a fraud checker interface. You have a payment gateway handler, instrument validator. And then whenever you are going to have a card, bank card, basic validator, you are going to see it will implement specific interfaces altogether, right? Base bank card, this will be this, right? Credit card will be extending now base bank card. And what does base bank card implements? iPayment instrument, and so on. So you're actually segregating out the possibilities, or you can say behaviors, into individual interfaces altogether. Does that point make sense, guys? Is the Liskov substitution principle making sense to everyone? Any questions? Now, is this in your head or not? दिमाग में गया या नहीं गया? Cool. So there is a nice article on Liskov substitution principle that I found on Medium. Let me share that with you guys. Okay, where is it going? Medium.com. Okay. There's a nice article that I would like to share with you guys on Discord. So, 1 second. You can go through this article. This also talks about a similar credit card, debit card kind of implementation. Okay. So read about it. On the same group, what is Sanket reading today? I've shared that article. Okay. So you guys can check it out. Okay. Cool. Makes sense. And also, I'll also share the refactoring.io link. Refactoring.io. Liskov substitution. Okay. This one. Let me share that as well. Cool. Make sense? Getting my point, guys? Let's see if they have given some nice examples. Okay. I'll go through this article. I guess this also is nice. I'll check if this is relevant, and if yes, then I'll share you this one as well. If it is just a normal one, then I'll not. But yeah, that was Liskov substitution principle for you guys. Any questions, anyone? Now, we have done SOL from the solid. Single responsibility principle is done. Open close principle is done. Liskov substitution principle is done. Now we are left with I and D. Trust me, I and D are the most simplest. That's why I want you guys to research about I. I stands for, anyone? Interface segregation principle. Okay. Read about what is I, when is I used, and trust me, it is very similar to Liskov substitution principle. It's kind of like an extended version of Liskov substitution principle only. That is the interface segregation principle. Read about what is interface segregation principle, how do we use it, and in the next class, you guys will give me some real life situations in some real life application where you might use interface segregation principle. Make sense, guys? And these principles, these solid principles are very important because later when we'll start with design patterns, you will see that every design pattern will be resolving issues from one of these principles only. And that's going to be very important. I don't think that's the right way to start with, Akshat. We have different layers for business and data access. So what? Give me a situation that you were implementing this app, right? Abhijit, I've already shared. Check the group of what is Sanket reading today. I've already shared the article there. Yep. Do check it out. Do check out the I from the solid and we'll start the discussion. I mean, for I, no, I want you guys to figure out yourself. मतलब मैं तो सीधा वन शॉट भी भेज सकता हूँ कि ये वाला आर्टिकल पढ़ लिया सब समझ में आ गया बट आई वांट यू गाइस टू फिगर आउट योरसेल्फ मतलब थोड़ा गूगल करना सीखो स्टैक ओवरफ्लो पे पढ़ो किसी का आर्टिकल देखो कुछ बनाने की कोशिश करो एंड देन लेट्स सी इफ यू आर एबल टू गेट समथिंग और नॉट मेक सेंस okay so I hope you guys are enjoying the LLD part. I'm trying to make sure that we keep the situation as real life as possible, right? जितना हो सके बर्ड कैट डॉग वाले एग्जांपल से हम दूर चलने की कोशिश कर रहे हैं, right? So let's try to continue this journey in the next class as well. We are going to meet soon in the next set of sessions. Till then, take care, guys. Bye bye. Have a really lovely week ahead. Happy New Year, in case I missed that earlier, and keep coding, guys.